So thank you all again. Good evening. Welcome to this special event. We're really excited to have you here. My name is Monica Ellis. I'm the Executive Director of Lifetime Engagement at WPI. Wanted to go through a few housekeeping items with you before we dive into the program. First, I wanted everyone to know that we're going to be recording this event so that you have an opportunity to view it again later. The chat feature is going to be able to be activated to be used. We'll be sharing a few links and things in that for you throughout the course of the event to share some of the information that we're talking about. But that is primarily for us to share information with you. During the program itself, if you have questions, please use the Q&A feature. We'll be using that as a way to share questions with the panelists and answer those questions at the end of the program. If anyone needs to, you have the ability to reset the view on your screen to optimize your viewing. You can click on the video window and relocate where it's located. We suggest the side-by-side viewing for a program like this. It works well to be able to see both the speaker as well as the presentation. Thank you all again for joining us. As I mentioned, we have a fantastic turnout this evening, and we have alumni registered from around the country, as well as some parents and members of the faculty and staff at WPI. We've got people from Alaska, Arizona, California, Colorado, Connecticut, Delaware, Florida, Hawaii, Illinois, Massachusetts, Maryland, Maine, Michigan, Minnesota, New Hampshire, New Jersey, New York, Ohio, Oregon, Pennsylvania, Rhode Island, South Carolina, Texas, Virginia, Vermont, Washington, and Wisconsin. So really a fantastic range of locations. So thank you all from far and near for participating and being here with us tonight. This event today is part of our Ask Me Anything series, which we kicked off back in September. If you were not able to participate in the Ask Me Anything events, you can find them online in our virtual event library, along with videos from some of our other events that took place this year. And we're going to be putting a link to that video library in the chat for you so that you have an opportunity to go and check it out and look at some of our other programs. We're really excited to have this esteemed panel of faculty with us tonight to discuss the science of stress. And to get us started, I am pleased to introduce our moderator, Dean Jean King. Jean is the WPI Peterson Family Dean in the School of Arts and Sciences. She also serves as a professor of biology and biotechnology, an affiliate professor in biomedical engineering department, a professor in the neuroscience program, and is the director of WPI's new Neurotech suite. We're delighted to have her with us at WPI, and she's an established researcher and accomplished educator. Throughout her career, she's published over 100 scientific publications. She served as a consultant for groups like the National Science Foundation, National Institute of Health, and the Veterans Administration. So we are delighted to have her here to moderate this program for us. And with that, I'm going to turn it over to you, Jean.
Monica, thank you so much for that great introduction. I really am delighted to be here and delighted to moderate the panel. But before we get started, I have two of our great colleagues to introduce to you. First up, Angela Rodriguez. Angela is an assistant professor of psychological and cognitive sciences and a faculty member in WPI Neuroscience Initiative. She directs the WPI Stigma, Eating, and Endocrinology Dynamics Lab. Her work focuses on a biopsychosocial approach to study health and health behaviors. She conducts research at the intersection of social phenomena like weight stigma, biomarkers, and psychological factors such as perceived stress and pain-related distress. Dr. Rodriguez joined us from UCLA, where she got her PhD in health psychology in 2018. She has been featured in the New York Times and also on NPR. Our next faculty that's going to be speaking to you today is Erin Sullivan. Erin is also an assistant professor at WPI, however, in the computer science department. Her research focused on human-computer interaction. She designs, builds, and evaluates interactive computing systems that use machine learning approaches to adapt and support a user's changing cognitive state and context. Her work has applications in areas such as education, transportation, medicine, and complex decision-making. Dr. Sullivan has a bachelor's in computer science from Harvard College. She has both an MS and a PhD in computer science from Tufts University, and she did her postdoc work at MIT. Erin also joined us in 2018, and she has also been featured on Boston CBS and Channel 3 News. Now, we have these two professors who have joined us in 2018 because we started a neuroscience initiative here at WPI. And I have to say, I am beyond delighted, and I'm going to tell you much more about that initiative when it comes around to my presentation. But to get us started, I'd like to introduce Angela again, to have Angela start us off. Angela Rodriguez, please start us off.
Thanks so much, Jean, for that introduction. So I'm going to kick things off tonight with the very big picture surrounding stress. So moving along to the next slide, I'm guessing most of you are here because the topic of stress piqued your interest. It's something most of us know all too well. And in fact, even when we're not in a global pandemic, research shows that 75% of us report being stressed out. But here's the real question I want to start off with, my million-dollar question. What is stress? I'm sure you're all acutely aware of what stress feels like, but it's really hard to put it into words, to define what stress is. I'm going to try to do that on our next slide, because when we think about stress, or at least when Google Images thinks of stress, most of what pops up gets at feelings. Feeling stressed out, feeling anxious, feeling worried, feeling overwhelmed. But it usually comes from situations, work or juggling multiple responsibilities, or being isolated from social support in the midst of a pandemic. Basically, our environment can conjure countless sources of stress. Next slide. And even though stress comes at us from the environment, it creates these very real feelings. And very unhelpful people like to say, oh, well, it's all in your head. It's just a feeling. Don't let it get to you. And don't get me wrong, stress, it definitely involves your head. In fact, the brain is inextricably implicated in our experience of stress and how we respond to it. But to say it's all in your head is really a gross oversimplification, and it misses half the story. Now, sometimes we can reappraise our stressors. Maybe we decide that a stressor can't harm us or that we have the ability to cope with it. Then we can keep stress mostly in our heads. But when we can't, what you'll see on the next slide, then stress isn't just in our heads. Stress is very much all over our entire bodies. Stress engages literally every single physiological system in the body. And this physiological activity can have a really marked impact for our health. So I'm going to give you an example that I think a lot of us probably can relate to on the next slide, which is stress eating. So I certainly know that I am regularly guilty of stress eating or stress snacking or eating my feelings. But what's going on with stress eating is not entirely psychological. Now, I'm not saying that that cake wouldn't make me feel better, but it's not just that we feel bad and then food makes us feel better. In my work, where I study eating behaviors and weight, I focus on a particular branch of the stress response that has direct implications here. And that's what you'll see on the next slide. So here's my diagram of the hypothalamic pituitary adrenal axis. And without getting too nitty-gritty into the biology, basically stress from your environment filters through the hypothalamus in the brain and then all the way down to the adrenal glands to produce the stress hormone cortisol. So here truly, our feelings of stress are turning into something that you can measure in a physical specimen. That's the cortisol. So when you're really stressed out, your body creates more cortisol that drives you to eat more, and then you store that energy that you've eaten as fat. And this is just one example to highlight how stress has these interrelated pieces, that environmental piece, the psychological piece, and then also that biological output that we can measure in a sample, usually blood or saliva, which is why to truly understand stress, we need an integrated model, which I'll show you on the next slide. So we really have to think of stress as this biopsychosocial construct. It might start in our social world, it filters through the brain and our cognitive processes, and it has measurable physiological outputs all over our bodies, outputs that then feed back into our brains, into our thoughts, our feelings, and how we go on to interact with the environment. So stress isn't just like the sum of these three parts, it's really the nexus of these three interrelated pieces. And as stress researchers, we may study just one or two of them to try to infer the others or to contextualize the whole big picture, whether we're looking at a biospecimen or asking about feelings. But it's important to realize that understanding stress requires this really integrated and interdisciplinary approach. So now that I have more or less defined stress, on the next slide, I want to get into the problem with stress. So our stress response developed to help us escape situations like this. The stress response is meant to mobilize our body's energy to escape an immediate threat to our physical safety or to our lives. And in the process, the stress response shuts down anything our body doesn't need to waste energy on in that moment of needing to escape. Processes like digestion and reproduction. So when you have to escape a predator, your stress response is definitely your best friend. But if we could all see each other today at this event, I'd ask for a show of hands of who has ever found themselves in this situation that you see here. And nobody would raise their hands because, of course, saber-toothed tigers are extinct. So I might say, when have you run from a lion or a tiger or a bear? Oh my. And I'm guessing that most hands would be down. My hands would be down for sure. Because if you recall what Google Images had to say, I'll remind you on the next slide, most of the stressors that we experience today are psychological and they're chronic. That means they don't pose an immediate physical harm from which we must escape, but they also don't go away quickly. These are things like financial strain, work stress, caregiving. These are chronic situations. But these chronic psychological stressors still engage the same exact stress response. Our stress response doesn't know the difference between a predator versus worrying about our work. And because these chronic stressors can go on indefinitely, although we wish they wouldn't, that means that the threat is never truly over. And our stress response system just runs and runs and runs on end. Now remember, the stress response alters our physiology. It ramps some things up, it shuts some things down in our body. And when we can't escape the stressor that never goes away, then that altered physiology never gets the chance to go back to normal. And this promotes physiological dysregulation and ultimately ill health all over the body. I'll give you some examples on the next slide. So I'm not going to go through every one of these consequences of stress and then how it affects health in the long term, but suffice to say that over time, experiencing this chronic psychological stress, this stress that all started in your head, will filter its way to wreak havoc on your entire body. All the way from increasing risk for cardiovascular disease, impairing our ability to fight infections, and even accelerating our aging all the way at the cellular level. So on the next slide, I want to exemplify the truly biopsychosocial fabric of stress and its consequences. And to do that, I'll quickly go through one of my recent findings. So this is really truly a hot off the presses finding. It's all too relevant today, considering that discrimination is one of the most pervasive challenges that our society faces. These data come from a study that followed Latina mothers over their pregnancy and then into the postpartum period after they had their baby. And the key thing that we were looking at was prenatal discrimination and whether we could use that to predict postnatal symptoms like depression and anxiety. And we did indeed find that discrimination was a really strong predictor of postnatal symptoms. So basically, this very social stressor, discrimination, had really long-term consequences for mental health. But wait, there is more. So it gets even more exciting because in this study, we also used blood samples to assess DNA methylation of various genes, including genes that regulate the body's inflammatory and immune responses. And that's really important because there's a lot of literature showing that inflammation and depression are pretty closely linked. And it turned out that DNA methylation had an important role in this finding, which I'll walk you through on the next slide. So all the action here depended on methylation of the FOXP3 gene. This is a gene that's critical for the body to be able to regulate the immune system. So when this gene becomes methylated, the body can't quite shut off the immune system when it needs to. And we found that in people with low FOXP3 methylation, that bottom box there that's highlighted, discrimination was not related to these negative outcomes. But as you'll see on the next slide, in people with high FOXP3 methylation, so less capacity to regulate the immune system, then discrimination was predictive of postpartum depression and anxiety. And we even took it one step further. We also looked at methylation of TNF-alpha, another gene that regulates inflammation. And we found that in this high FOXP3 group, then we saw prenatal discrimination predicted greater methylation of the TNF-alpha promoter region, and that in turn predicted greater postnatal symptoms of depression and anxiety. So the take home is that epigenetic markers of immune function, all the way to DNA level, play an important role in resilience and sensitivity to prenatal social stress. So a truly biopsychosocial integration here, looking at social stress, influencing methylation, influencing mental health. But I don't want to leave us with this very bleak picture that like we're all doomed to have our health and well-being destroyed by our stress. So on the next slide, I want to show you that in fact, there are many, many ways that we can effectively cope with stress. And it's really critical that we learn how to do these strategies and that we do them regularly. So I've highlighted the most scientifically supported strategies, things like exercise, meditation, journaling, getting good sleep. These things all make us more resilient to stress. And that means that when the unavoidable stressors come along, when we experience discrimination or work stress or a global pandemic that you cannot get away from, we can rely on our coping skills to mitigate the impact on us and to recover quickly from that stress. So I really can't emphasize enough, you should definitely cultivate these coping resources because a healthy lifestyle can help us bounce back from the stress that we face. But here's what I want to leave you with on the next slide. What if we could nip stress in the bud? What if we could stop stress from engaging our physiology in the first place? To answer this, to really understand how a stressor is translated into a stress response in the body, that requires understanding the brain's role in stress. And the big question is this: how do we engineer resilience so that the brain doesn't even initiate that physiological stress response when it perceives a stressor? So this is why at WPI, we've started an entire neuroscience program, which Dean King is going to talk about more in a bit. And in a very WPI way, we're hoping to fuse technology with neuroscience to better understand the brain and to maybe even engineer environments that help us to prevent stress. And that's something you'll hear about next. So with that, I'm really excited. I get to turn it over to my colleague, Erin Sullivan, who is, as you heard, an assistant professor of computer science. She came to WPI at the very same time as me, and she's going to talk about her groundbreaking work on human-computer interfaces. So go ahead and take it away, Erin.
Okay, thanks, Angela. That was such a great overview of stress, and I think we all learned something. And nothing seems more relevant today than understanding stress and what we can do to reduce it and strengthen our resiliency and coping mechanisms. So now I'm a computer scientist, and I'm sure many of you are engineers, computer scientists, or in some way involved in developing technology. And let's face it, technology tends to be a source of stress also for many people. So today I'm going to discuss some of the research my students at WPI are doing to create technology that is more adaptive to human stress. This research is in a new area of computer science at the intersection of human-computer interaction, neuroscience, and data science. And it builds directly on the scientific foundations that Angela just discussed and takes advantage of recent advances in neurotechnology to decode the brain and biosensor stress signals in real time. So first, let's think about how you interact with technology today, whether it's your laptop, your tablet, smartphone, your smart home, the car you drive. Usually you give it some input via keyboard, mouse, touchscreen, or voice. But these techniques do not fully capture the richness of your thoughts, your intentions, and your feelings when you're interacting with technology. So if we go to the next slide. For example, when we communicate with other people, we do not simply use words, but also visual and auditory cues that give the other person additional insight to our stress level. And then they may adapt their behavior or what they're saying based on what they can infer from you. At the same time, as Angela just showed us, several physiological changes occur that may or may not be detected by the other person, but they happen automatically. When we communicate with technologies, we also generate these additional signals, but the technology doesn't sense these signals and completely ignores them. So next slide. So there's been a growing body of recent research showing the feasibility of using non-invasive brain and body sensors as input into technology and interactive systems. And the goal with this is to increase the bandwidth between the human and the technology. And so what we're doing in my lab is using non-invasive methods to pick up additional signals that we're naturally giving off all the time as our stress level changes, as our emotions change, and translate that into meaningful input that leads to technology that responds appropriately to changes in the user state. And so if we can trigger these smart behaviors, then the technology can be more adaptive. So emerging research is providing more practical brain measurement tools as well as greater understanding of brain function. And this is going to continue through all the national investments, such as the US Brain Initiative, which is funding some of my research, as well as the commercialization of wearable technology containing brain sensors and other biosensors. This is opening up many research directions. And so the pictures on the right show some of the sensors I've been working with. There's EKG, skin conductance, and then FNIR's brain sensing, which I'll talk about and explain a little bit more later. So all of this is continuing to develop and commercialize, and they provide these real-time continuous measures of these physiological changes that Angela was talking about. And they also have more and more, they have a quick setup time, they're more comfortable and portable, and really allow us to take these measurements in the real world while you're doing your normal everyday tasks. And this is creating so many opportunities to build these intelligent and understanding technologies. Okay, next slide. Next slide. Okay, so to make this more concrete, I'm going to shift to some work that I'm doing in collaboration with the MIT Age Lab, looking at something that causes stress for many people, and that's driving. And specifically, we're looking at driving while also trying to do a secondary task. So, you know, whether it's, well, I'll talk about that in a minute. Next slide. I don't know if there's a delay on my, okay. So our approach is to do this passive physiological monitoring during natural on-road driving. And so we did a study where we gave participants additional stressors from a secondary task that they had to do while driving. And the secondary task was intended to be a proxy for tasks like rerouting your GPS or calming down an unhappy kid while trying to safely drive. I don't know if anyone knows what I'm talking about, but it's stressful. Okay, so the next slide. So while we can collect all these signals, and then we can build a model of stress during driving, allowing for this measure where we could get in real time a continuous measure of how our stress level is changing. And this could be used to evaluate new technology being introduced into a vehicle and how it introduces stress, or it could even be used eventually in real time to adapt the behavior of the system. So your car could be more supportive of the changing state that you're in. Okay, next slide. So in our research, we showed successful machine learning classification that could identify when the person was driving, just calmly driving, from when they had that additional stressor. And what these pictures are showing, the blue and red, so along the x-axis and all of those is time. So it's the whole session of driving. And what you can kind of see is where you see it more red, that was when they were doing a secondary task. And on the top, we're looking at heart rate, and on the bottom, it's your skin conductance, which is basically changes in your sweat glands in your skin. And so we could really clearly see that there were these physiological changes that we could measure while we were giving them the secondary task to do. Our studies included over 100 men and women in 3 different age groups driving on the real highway. And my goal with this was really to see, could we do this type of sensing in the real world outside of a lab? And we're hoping that this moves it closer to the real world. Okay, so next slide. So now, knowing that we can detect stress levels, we can work towards building adaptive systems and adaptive technology that's based on these brain and body inputs. And whenever we're doing this, it kind of involves, no matter what the task, they usually involve all of these steps. So a lot of the research in my lab involves different aspects of these steps. So the user's performing a task that creates some kind of stress or change in their cognitive state, and that generates brain activity and physiological changes. We do some signal detection using the various sensors that we have. And then from that, we take the data, we have to do some pre-processing to get rid of noise and artifacts. And then we use machine learning to build these models of the different states that we're looking for, and then to later classify them from the signals. And then once we have this classification, we can interpret the cognitive state information given the task that someone's doing or the context that they're in, and build these adaptive interfaces. And this is a lot of what's going on in my lab at WPI. Okay, next slide. So now I was talking about physiological changes. The other thing that we're trying to do is see if we could decode stress in the brain in real time. And so to talk about that, I'll discuss some of my work with FNIRS. It's functional near infrared spectroscopy, which is an emerging brain imaging technique. It's less known than some of the other sensors that I've used. It was originally developed for clinical purposes, but it has these characteristics that make it more practical for everyday settings. As you can see in these pictures, someone is wearing a cap. So it is a cap that you have to wear and it has sensors, but more and more work is making these smaller and less invasive and even portable and wireless. And it provides a continuous real-time measure of blood oxygenation in the brain while staying portable and less constraining than most brain sensing and imaging techniques. And so this allows us to really study the brain in the real world, doing real things and under real stress levels. Okay, next slide. So since it's a newer technology, I'll talk a little bit about how it works. So it's actually using light, near infrared light, and that's why it's called functional near infrared spectroscopy. So light goes in through these sources that are on the cap. And you can see the light sources in the cap, they're the red and the light detectors are blue. So the diagram shows the way that FNIRS works. So the light sources, and you can click, send 2 wavelengths of light in the near infrared wavelength into the brain, into the forehead, where it continues, if you click, through under the skin and into the cortex, and it goes about 1 to 3 centimeters deep into the cortex. The biological tissues are relatively transparent to these wavelengths, but the oxygenated and deoxygenated hemoglobin or blood are the main absorbers of this light. So light scatters in the brain and some of it reaches the light detector. Click. And by determining the amount of light that's picked up by this light detector on the other side, we can calculate the amount of oxygenated and deoxygenated hemoglobin in the area. And this is an indicator of brain activation in this area. So all that is happening in the cap, or it can also be in a headband, as you can see on the left. Okay, click. So we were also interested in exploring the additional insights we can get if we monitor brain activity during driving and secondary tasks. And we actually carried out a very similar study to the on-road study that I talked about before, but this one we did in a driving simulator just because we had a cap on and we didn't want to, so we did, it was a full car, as you can see in the picture, but they're not actually on the road. There's a big, huge screen all around them so that they can drive. They use the steering wheel just like they normally would. And so we did a very similar task where we had them drive and then we gave them a stressful extra task to do. And then we developed an advanced deep learning framework for classifying the driver stress using the brain data. I won't go into all the details, but if anyone's interested, I'm happy to talk more about it later, but we use convolutional autoencoder and echo state network autoencoder for extracting the features. And really the main point is that we're building a foundation for using FNIRS to measure driver stress in real world applications. Okay, next slide. Oops. So other work that I'm really excited about is our new ability at WPI to collect FNIRS and fMRI data at the same time. So FNIRS, so the picture on the right is another picture with my student wearing an FNIRS cap while walking around. So you can see it's portable, it's wireless. But we also have an FNIRS device that can go inside an MRI machine, which is what you see on the left, which people might be more familiar with. So fMRI is what neuroscientists like Jean have been using to build deeper understanding of how the brain works. But as you can see, it is a bit constraining and you definitely couldn't drive a car while inside of it. But by simultaneously collecting FNIRS data while in the fMRI, we can get comprehensive information and start to transition what we learn from MRI to fMRI to more mobile, portable, less constrained FNIRS measurements. And then in addition to driving, I'm also looking into many other domains. For example, we have a $1 million NSF grant to explore brain signals during learning. And I've also looked at how real-time brain signals can be used to adapt video games and to be used in medicine, aviation, and other domains. But I'm truly excited because there's so much potential to translate some of this basic science insights that Angela was talking about what we know about stress and different aspects of how that impacts our body and our brain, and build more intelligent technology that's truly human-centered. And so with that, I'll turn the program back over to Jean, who will talk about her work.
Thank you so much, Angela and Erin. Wonderful. I could listen all night. Unfortunately, we don't have all night, so I'm going to try to get through this quickly so we could get to the questions. So as you could tell from my slide, the title of my talk today is actually from Hans Selye, and he is the father of stress. The stress research started with him. He's a Hungarian, and then he was a physiologist who actually coined the word stress in this regard, in the way we are using stress from the physics use of the word stress. And he said, he has many quotes, by the way, if you have time to ever Google him, he has many, many great quotes. And this one I really liked for tonight. So he said, to be totally without stress is to be dead. Obviously, that's not what we want for you. So we want you to be able to understand what's good stress, what's not so good, and how actually to get from where you are to where you need to be by being resilient to that stress. So we all are going to go through stress every single day as how we actually react to stress. So we're going to talk a little bit about that. But what I want you to do for a couple of seconds, just for the next 10 seconds, is to think about the last time you were in a stressful situation. I'll give you a second to think about it. And then I would like you to think about what your reaction was. How did you react? And if you hold that thought, we're going to get back to it. So next slide, please. So here's my journey. Why am I actually engaged in stress research? I've been doing this for over 20 years, more like 30 years. I started as a graduate student, not knowing what I wanted to do. I know I liked science, which is why this is my way of looking at the world. I really liked math and I liked physics. I liked everything. It drove my parents crazy. I was the kid that needed to go to school to find themselves, except I couldn't do it very quickly. I kept going from one science to the next. I knew I liked science because that's the only thing I could do, but I can't tell you which one I liked. So here I am in graduate school and I'm deciding to be a molecular biologist because all my friends are becoming molecular biologists. And I go to a course with, actually it was just a lecture with one of my friends because I just wanted to figure out what she was doing with her time. And I walked in and there was a neuroscientist giving a neuroscience lecture. He was from Rockefeller University and one of the colleagues of Hans Selye, the person I just told you about. And he got through this lecture about the brain. And I sat fascinated thinking, I can't believe I didn't know this. I've been a biologist for several years. I was in graduate school, so I was 21, but I thought I should know everything about the brain and I didn't. And then he said the following words that got me. This is the most complex living structure in the known universe. And all of a sudden I went from the very confused graduate student as to how I was going to spend the rest of my life to knowing exactly what I wanted to do. As it turns out, this coincided with me going to the morgue to see an autopsy. And when they got to the brain and I was able to look at the human brain and actually hold this in my hands, a 3-pound mass of tissue that was in fact the most complex living structure in the known universe, I knew I had found my calling. This was what I wanted to do for the rest of my life. Next slide, please. And why is that so complex? Why is the brain so complex? Well, the brain is this complex because it has over 150 billion with a B cells. And you remember what cells are from your days back in college and these little individual cells that do all of the work that they need to do a particular task. Well, here they are in the brain, this 3-pound mass with over 150 billion of these cells. But that's not what the most exciting part is. The most exciting part is each of these cells communicate with cells, some in their local areas and some communicate outside of their zip code. So different cells communicate differently, but they all communicate with each other, not just with a single other, but with several others. So this is a network, and which is what you're seeing here, a network of cells talking to each other constantly, even when we sleep. These neurons are interacting, they're talking, they're sending information, they're communicating in a massive way. That was the most exciting thing I thought about. And knowing that we could actually study that was something that I thought would obviously take forever to study, and which is why Erin related the decade of the brain, which started in the 90s, and the whole of the scientific community started studying the brain in a massive way. And I was grateful to be one of those people trying to do that. But how does that relate to stress? Next slide, please. Well, in certain of those areas that I talked about in the brain is like a city. So Boston is responsible for doing something and Northborough is doing something else. And it's not that they don't communicate, but they sort of have their responsibilities. They know what they need to do to get through the day. And that's sort of their responsibility. Now, if you look on the right side of the screen and you see this label called the prefrontal cortex, that's the part of the brain right here where we sort of make decisions, where we think about stuff, where we get all of the information in to make what I would say more logical decisions. And then you see another label, it's called the amygdala, it's that little piece at the bottom. That's where most of the decisions are emotional, right? That's where we respond emotionally. Well, the best way to do that is to have an interaction between how we think about stuff logically and how we feel about it. So we could decide on what we want to do about it, right? Is that interaction. Well, those two things come together. So thinking about how you responded to the last stressor, we'll talk about, was that an interaction or did you respond from the emotional side or did you really think about your response and respond that way? We'll talk about it a little more. But what we found in those two areas, under chronic stress, which Angela referred to, those regions, the top are controls. After stress, the bottom says chronic stress. It's the same neuron. And you could tell all of those little fingers are connections. That's how they connect to each other. So you lost connections with chronic stress. Both times, the prefrontal area, that area I talked to you about, and the emotional area, both lost contact. So that means their ability to do their jobs was less than their abilities to do their jobs when they weren't stressed. But this is chronic stress. This doesn't happen in an instant, but this happens over a long period of time. And I really wanted to understand when they lose connections, what happened to the other connections they had? What happens to their neighbor? Does the neighbor lose connections also? And how is that? What happens? How do they interact after they have lost connection with each other? And are there ways that we could bring them back together? Because what we really want to do is not have a disease state, but how could we heal? Next slide, please. So again, this chronic stress. Most of my research studied not just the stress response that Angela talked about, but how that could lead us to unhealthy behaviors. Because one of the ways we deal with stress sometimes is to respond. Angela talked about emotional eating, cigarette smoking, alcohol. These are fine things on a normal day. It's not okay if that's how you're dealing with your stresses. And that's the important thing, which is very complicated because you want to do these things. And in a regular situation, they're fine. So when do they become a problem? They become a problem when they become a habit. And when they become a habit, they go back into that stress response because now it's a habit. You have a problem. The stress response is now regulated by that problem and it goes forward. It's a circle, it's a cycle. And that's the cycle we need to get out of. So that's what I was trying to understand. Either the stress response, which I did a lot at the molecular level. I was a very basic scientist before I started looking inside the brain, which is what we're going to talk about next. So to get to habit though, I had to see inside the brain. I had to see how the brain was functioning, not just in response to one thing, but how it responded over time. Next slide, please. So we needed some innovation. We really needed to figure out how to non-invasively look inside the brain. Next slide, please. So I was clear that if I needed innovation, this is when I wanted to pull in all my engineers who are friends, because I now had a problem and I knew what the problem was and I knew what I wanted to solve. And I was lucky enough, although I was a faculty member at UMass Medical School, to come here to WPI at that point and ask our colleagues here at WPI, could you help us solve this problem? I need to be able to look in the brain non-invasively, which means I don't want to kill the animal or the person I'm looking at. I just wanted to go into the brain, understand what's happening because those connections were so important. I wanted to know when you lost connection, what really happened. We got together with two colleagues who are still here at WPI, Reinhold Ludwig and John Sullivan, along with another colleague of mine, Craig Ferris, who is next to me at the top of the image. We got together and both schools, WPI and UMass, came together, gave resources. So my joke about this is I built myself what you see here is a trailer. It took me my entire life to build. And we built that from the ground up. From that, we got a lot of patents, which we found the company and all of this went on and on. But basically, we went to the engineers because we had a problem to solve. I wanted to be able to see those networks. So next slide, please. We were able to do that with one thing. We needed to have models. We had humans and we had preclinical models. And this is a model of smoking because I did a lot of my work on smoking and alcohol and cocaine and marijuana. If there's a drug, we have actually used it in the lab. Next slide, please. And what did we find out? Well, we found out When there's a stressor, by the way, both alcohol and nicotine releases that cortisol that Angela talked about. So when you do all of, especially with cigarette smoking, your cortisol level increases and it goes back into that stress response system that we don't have enough time to tell you about. But what I found, that if you look to the left of the image, that's how those connections happen. It's called DTI. It's a particular way we use fMRI that Erin told you about briefly, and that became our work. We started to use fMRI to understand the brain because we could look non-invasively. And what we found out was those connections were in fact impacted. And what you see on the other side, A, B, and C, those are slides from the brains of humans, some of whom were smokers and they stopped smoking, and some of whom continued to smoke. And what we saw was when you stopped smoking, your brain actually went back, not all the way back to a non-smoker, but it actually did repair. And the people who continued to smoke, the connections between these brain areas started to fray and continued to fray. And we had lost connections in those smokers, especially if they started to smoke really early in life, like 10 and 11, and if they were continuing to smoke like 60 and 70. So this was a whole human study, and we were able to show the things that I just talked about. We were able to show the connections, and we were able to show that stress, in fact, impacted it. Next slide, please. We are also able to show that chronic stress is different from acute stress. So A is just the brain. B is the brain with acute stress, which means it's just a sudden stress. You respond to it and it's over. If it's C, where you're responding over and over and over to the same stress, what you could tell from the red is recruits all of the brain areas. So most of the brain is recruited with chronic stress, which is why it's so dangerous for you and what Angela was speaking to you about. B is, activation, and you could deal with it. But C is the kind of activation that's so much and so varied that is very difficult to deal with. We also were able to show that chemistry changed. We also were able to show that receptor change, which is the top of the right, and the bottom is that chemistry change. All of this we were able to show with fMRI tools. We're able to look at the structure, we're able to look at the function, which is the first slide, and we're able to look at the chemistry. So those technologies were able to actually look at not just function and structure and chemistry, but able to tell us how the brain was actually functioning, because that's the most important thing. You're really not going to know if the brain changes in structure, but you're going to know if you change your function. If you're not functioning the way you used to, you would be aware of it. The next slide, please. So it's not stress that kills us. It's our reaction to it. I told you, Hans Selye has a lot of these. And that's the important thing. It's not the stress, it's how we reacted. So again, getting back to you, how did you react to that stressful moment? Were you able to stop the stressor? Were you able to be resilient to the stressor? Did you find coping mechanisms, or was it more difficult than that? Well, for most of us, it is on a regular basis. Next slide, please. So we set out to try to figure out what are ways that we could actually help our brain. As it turns out, John Kabat-Zinn, for those of you who know what mindfulness is, mindfulness-based stress reduction was invented at UMass Medical School, not mindfulness. That came with hundreds and hundreds of years. But the stress reduction and its approach to using mindfulness meditation to reduce stress started with John Kabat-Zinn. And if you have a chance, you should actually look at The Full Catastrophe Living, which is his book about how this came to be. Well, he was on the same floor with me as a young faculty. So I was an assistant faculty like Erin and Angela, and I would run into him in the hallway all the time. And I said, what are you doing with this stress stuff? He goes, I know you're a stress researcher, we should talk about this. To be honest, at that point in my career, the idea of meditation didn't sound like something I wanted to think about, I wanted to do, or I wanted to explore in terms of science. It just didn't feel like it was the hard science I wanted to do. So I really ignored him for a very long time. Next slide, please. So these results came out and they changed my mind. What we saw, that area I told you about, the prefrontal cortex right here where you make decisions, in people who are experienced meditators who have been meditating for a very long time, the thickness of that area increased. And basically what that meant in terms of my connections I'm telling you about, the connections increased. Remember I told you with stress, the connections decreased? Here was a way that the connections were increasing with just meditation. So that got me to think about, could we show that? Could we do studies to see if this was really true? Because I'm not sure I was really clear that that was really true, being the hard neuroscientist that I am. So next slide, please. If in fact that was true, how did it do that? How did it work? Could it actually change the behaviors that I was thinking about? So I thought about an experiment. If we're able to see that it changed the behavior of people who were experiencing unhealthy behaviors, I may actually think it works. Next slide, please. So we developed a study with people who are emotional eaters. We brought them to UMass. We decided that they were emotional eaters. There are lots of surveys that allow you to see that somebody's an emotional eater. And then we engaged them in an MBSR program for 8 weeks. We were able to teach them meditation, and we taught them how to deal with their stress. And guess what? The connections between those same 2 areas that I told you about increased in the people who would use meditation. They're all emotional eaters. The connections with those who actually do the meditation increased. It strengthened the connections for people who actually took the meditation, continued to be emotional eaters, but they didn't eat as much. Their weight went down and the connections in their brain actually increased. And that's going to be actually published in the next week or so. And we just got the papers back, so it's going to be in publication in about a week. Next slide, please. So our lab had to think about this. Why practice mindfulness? How does it work? I became a convert because I finally did the science. I really didn't just go into meditation. I really wanted the science to make sense. And there are lots of science outside of our science that actually supports that. 60 Minutes came in and did a whole sort of week with us. We went to California together with this entire group with John Kabat-Zinn and did a study there and showed that with the brain, a similar brain cap like what Erin showed you, that the brain does change under mindfulness. So really what it does is it actually gives us gap between the stressor and our response. So people who meditate have a moment to think about how they want to respond. So they're not responding as quickly, they are thinking about it. So for the people who were emotional eaters, they stopped at the refrigerator door instead of actually taking something out. It's not like they didn't go through what they normally would go through, but they were able to stop themselves. And that's how we think mindfulness actually works. It doesn't stop you from the behavior, totally stop you and not have you think about it and all of those things. But as Angela says, it stays in your head. You are able to actually logically think through it and not move to the behavior that's in a behavior that's going to cause that habit loop to come back again. Next slide, please. So what does all of that have to do with it? I have studied lots of different things. And as you could tell from my 2 young colleagues that just presented, WPI is a place where there's so many interdisciplinary people working together. This is the most fun I've had in a very long time. So we started a program in neuroscience with 40 different faculty across the university who actually came together to study computational neuroscience. And most programs in neuroscience are neuroscience program and they're disease-based, and that's fine. Ours is computationally based because we're so tech-driven and we're so computationally driven. And we felt that's the best place to situate WPI in the neuroscience space. And I'm really excited about this. I have to give a big shout out to Jagan Srinivasan, Carolina Roos and Robert Dembski. They all help with different parts of the program, and all of the faculty here who are part of the program. I have to give a shout out to Erin on her grant, which she talked to you about, and to the Kasparian family, who gave us our first grant in neuroscience here at WPI to study depression and suicide. Thank you so much. Next slide, please. So this is our Neurotech suite, and we want to invite all of you to come down. Unfortunately, because of the pandemic, we didn't have an opening of this suite, but here are some of the wonderful technologies we have. I'm so excited to put all of these pieces together. So some of them we talked about before. You see the FNIRS, the fMRI, which I use. We have a shielded acoustic chamber. Angela just talked about that, where we could change your environment and see how you respond to changes in your environment, changes to light and sound. We have VR equipment, we have eye tracking equipment, and on and on and on. So please come visit us when you come to WPI. This is a way of blending tech, physiology, computation, psychology, neuroscience together to make something a little different. And the sensors at the top, we have a lot of people in the group that's just based on their sensor research. So next slide, please. This is a group of faculty, and this is the Neurotech suite. It's in Practice Point, which some of you may know what that is. This is actually at the point of practice, which really comes together. We have faculty from engineering, business, and arts and science. And when the global school comes in full force, I'm sure we're going to have faculty from the global school also. Next slide. I think that might be close to the end. The two pressing issues we're thinking about right now, we're studying depression, as I told you, with the Kasperian Fund, and several of us, including Angela and Erin, are working on a pain grant. And we now have a pain center where we're trying to figure out the interaction between stress and pain. Next slide, please. I think that's it. So thank you very much. I know that was a rush job. I had a lot to say, but we really want to hear your questions, and hopefully you could stay with us for an extra 5 minutes because we like to take some questions. So the first question, and I hope Angela and Erin can join me. Angela, I think I want to go to you and ask you from a question that came in from early registration. If you're feeling stressed, what are good, easy mental, physical activities that can be used on the spot?
Yeah, so I know I showed sort of my collage of coping mechanisms, and you can't always like go for a run when you're in the middle of a stressful call and you start to feel that stress setting in. But one thing I want to sort of start with is that while there's really good science on coping mechanisms, the most important thing is that something makes you feel like you can handle your stress better. So it doesn't really matter if the scientific paper says that XYZ strategy doesn't work. If it leads you to feel like, okay, actually I can handle this, you making that decision that you can handle something actually changes the physiological arms of the stress response that get engaged. So really just your ability to think critically and think about what resource you can pull in to be able to cope, that is a huge thing right there. And then something that everybody can do that is so overlooked, but it's like you don't need to be trained to do it. You don't need to pay for it, but just journaling. So writing about your stress, your traumas, and specifically finding meaning, like make that effort to find something meaningful. Write about this pandemic experience and write about the meaning that you found, whether it's appreciation for time with family or slowing down your life a little bit, and whatever meaning you can find when you journal and then you find that meaning, it has like lifelong health benefits. So I think, in addition to the exercise, yoga, meditation, these things that you sort of need to carve out an hour to do, there are also things you can do in 5 minutes as well.
Oh, thank you so much, Angela. So Erin, one of the questions that came in, can human-computer interactions be used to identify who will progress towards higher acuity disease states?
That's a good question. So, I mean, human-computer interaction encompasses many things. So I'm not sure exactly which part of it, but this is one of the things that I'm definitely interested, particularly with the brain sensing, being able to look at brain sensing in more throughout the day in realistic settings. We can look at using sensors that are more and more integrated into your everyday clothing and things like that. We might get to a point where sensors and technology are so ubiquitous that we are able to collect this data, build models, and identify patterns in what behaviors and what physiological responses do correlate with future disease states. And that's one of the things we're doing with this, we're trying to do with the future pain grants.
With the pain grants, yeah, which we're really excited.
But there's other stuff with human-computer interaction too, like just monitoring how you're typing, as you're typing, slowing down. So does that mean that your hands are getting stiffer and things like that? There is work in that type of thing too. It's not what I do, but HCI can be many different things.
And they did ask, and one quick question, and I think that Monica may have some questions for us about technologies you could use. So in terms of mindfulness, I use like the Insight timer on my phone, and the Headspace and the other ones, they're free apps that you could use to help you with this if you're not able to do it. So I just want you to know technology is also out there to help you with all of these things, like the Fitbit and other things for exercise. There are also programs for meditation, as Angela points out that she has hers on. Yes. Monica, are there any questions from us from the audience?
Well, there are a few that I'm happy to share. One of the ones that came up was sort of related to the conversation we talked about the chronic versus the longer term stress. And with the stresses that we've all been facing in this year with the pandemic and sort of the extended exposure and sort of chronic stress, what kind of things can you do to combat that longer term stress exposure? And the techniques you shared are great in those individual stress cases, but what can you do over a longer term basis?
Angela, you want to take that?
Yeah, I think in that, one, it's something we're kind of all still learning how to do. I'm not sure that I've quite mastered the pandemic stress release, but I think you have to make your coping mechanism as chronic as the stress is. So if it's exercising, then you make sure that that's something that you engage in just as regularly as, the pandemic's going on. So really it's an everyday thing. And so it's really about like prioritizing that stress reduction. So it's not as it comes up, it's going to come up. So you just have to build it into your day-to-day life. So it's as ubiquitous for you as the pandemic is.
That's terrific.
That is great. One of the things about the pandemic that's really, as a stress researcher, that stresses me out just thinking about it is the uncontrollable, unpredictable nature of the pandemic. So when we talk about chronic stress, it's a stress that's, for an extended period of time. This particular chronic stress comes with it, these other aspects of it, right? It's uncontrollable and it's unpredictable. And that's the worst stressor you could possibly under as a chronic stress. So this is a particularly difficult one. So if you're experiencing a lot of stress in this time, know that this makes sense for it to be this difficult because they have so many aspects of this. It's unprecedented, that's true too. But just the physiology of those things coming together makes it very, very difficult.
Fantastic. We had a question from somebody who's had experience with, because of the results of stress, they've had a number of physical and painful symptoms that doctors didn't initially identify as being stress related. And they were noticing that physicians don't always seem to assess symptoms on a systematic level. And they're wondering if some of these research tools that all of you are looking at are something that could be helpful to doctors in the future to get a better understanding of the root causes and stress and how that could be impacting the physiology.
Gosh, what's a great question. Absolutely wonderful. So I'll let my two other colleagues go at it first. Erin, do you want to go take that? And then we'll have Angela also talk from a health psychologist. Could you help people monitor any of this with your technologies?
So, I mean, I think that it is common. So sometimes because of what I think Angela would probably be better to talk about it, but I think of that model, that integrated model that we're talking about, sometimes things like pain and stress, they do get, sometimes the relationship between them and something that's actually wrong, it's not always easy to map your stress response to what was causing it. And so it's actually very common, I think, for doctors not to be able to put that together. So with the stuff I'm doing, I mean, this is something hopefully eventually we could get more into. We are trying to figure out, based on people's own assessment of their pain, how does that correlate with different physiological measures that we take? And every individual has different, if you ask someone how their pain is on a scale, they might give different responses for the same amount of pain. And so we're trying to make these individual models that really can identify for that person, how are they feeling? Because something that is painful to one person might not be as painful to someone else. And so then it might get dismissed because, oh, there's nothing that's big of a deal, but it's actually impacting their everyday life. So it is what we are working towards.
Yeah, we hope you're going to get there.
Yeah. So.
I'm not sure that, I mean, there's not really much to add because Erin gave such a great response there. I think the big picture issue is a lot of times just trying to reduce something down to one component. And the reason why stress is so misunderstood and why its causes and its consequences is because it's so multifaceted. And so I think this is where, in terms of like what can help physicians, I think this is really what we're trying to do, especially with the chronic pain group, integrating what somebody says about their pain with what sensed markers, like how they're walking, how they're sleeping, with what's going on in their brain, how we can really create an integrated picture to look at their biology, their psychology, and their social environment to really understand what's going on in a more in-depth level.
Totally agree. And again, that's the reason we have the Neurotech suite. We really want to provide objective measures of stress because it's this, it's the patient saying, here's how I feel. The doctor's like, I can't pick anything up to indicate that that's how you feel. So it's our way of trying to bring some objective measures as both of my colleagues said, to help physicians with that. So hopefully we could help. We're looking forward to that day. So Monica, could we take another question, or is that it?
No, I think, but we've got a ton of questions coming in, and we still have the majority of the audience. So I think we'll try to take a couple more if we can.
Okay.
We've had a couple of different people, I think as a good follow-up to what you were just talking about, a couple of people talking about some other types of physiological, so we talked in the presentation about how stress can have physiological consequences, but people also talked about how physiological conditions can sometimes also lead to stress, whether it's inflammatory diseases. Somebody asked, so we had somebody asking about inflammatory disease, somebody asking about diabetes, things that can actually be stress inducers themselves. So it can be a sort of a cyclical problem. And are there things that we can do to help in addressing some of the physical conditions, neurologically or behaviorally, that can help to reduce the stress and not cause more physiological problems down the road?
Okay, Angela, yawn.
That is like, I mean, I don't know. I guess according to NIH, it's probably the $100 million question.
It is. It is.
You know, how do you break the cycle? How do you interrupt it? And it's not going to be in one direction, because you know, at any point, if you can stop, you still have to like deal with as the cycle comes back around. So again, it goes back to, of course, mitigating stress, addressing, and this is where I think, especially in primary practice, thinking about, you know, addressing whatever is causing the dysregulation, whatever might be causing the symptoms, but also understanding that sometimes even once you like heal whatever is dysregulated, there's still distress that goes with it. And so, so treating the cause, but also treating the symptoms, both of these things sort of have to happen in tandem in a really like personalized behavioral medicine approach. But I mean, I wish I had the answer to it. And I think there's a lot of good minds working to get to that.
No, and I have to address that too, because I feel that people are in that chronic loop, and it's taking care of what that first thing is. So what is the chronic disease, and how do you take care of yourself? If it's diabetes, how do you bring down your A1C? You know, just sort of get into the disease, because that may help with that cycle back and forth. It's just very complicated, because I think if you focus on the stress and not on the disease, that's still going to be a complication, right, that you have to deal with. And in some cases, chronic disease are just chronic, and you have to figure out how to learn to live in a chronic situation. And that's not easy. I mean, we have a lot of people in the pain grant, and like Angela and Erin was saying, we have people who live with chronic pain, and they've been living with chronic pain for 20 years. So how do you deal with that? And there are ways that you could have some behavioral reappraisal to try to help. And I you know, I feel for those people, because I know how difficult it is.
Absolutely. Do any of you have any commentary on some of the technologies that are currently out there to help in managing stress, and whether or not you think those are effective? We talked a little bit today about using it to evaluate stress and sort of how the body behaves, but what about using technology from a stress management perspective?
And I'm not sure if they're talking about exercises, like what specific ones. Do either of you have a specific idea of what they're talking about necessarily?
Yeah, I could think about even one of the big drivers of stress is sometimes just like your elevated heart rate, and sort of you start to feel out of breath, and then we might appraise that elevated heart rate as anxiety, even when it could be because you had to climb the stairs really quickly to get up to your office. And so so there's like very simple like biofeedback sensors. So even just watching a timer that makes you slow down your breathing to go along with like very simple technology like that. If you have a Fitbit, you can actually watch your resting heart rate, watch your heart rate, and like slow your breathing to move your heart rate down. And then you can see how your body's actually responding to those simple things that you've done. So it's really good when technology can give you immediate feedback on how something you're doing might be affecting your physiological stress.
And I do like the heart rate monitors, because that's one thing that you could do. Breathing is everything, by the way. If you cannot figure out what to do and you're in a stressful moment, just breathe. Like, actually take a breath. We don't know how many times we actually are holding our breath. And then we're just like, just breathe. Like, just breathe. And I do the 1, 2, 3, just breathe when things are really difficult. So yeah, it's easy to do. We have it, we have it with us every day, all the time, but sometimes we don't pay attention to it.
Do are there opportunities for current WPI students to participate in any of this stress-related research?
Yeah, call us up.
Absolutely.
Anybody on here?
I have lots of undergrads in my lab.
Yes.
Excellent.
My lab
They
too.
both have a lot of students. I wish I could be in the lab more, but yes. Erin
Well,
and
we all wish we
I
could be
always
in the
looking
lab
for
right now.
students. They always looking for students. So please hit us up.
And Jean, somebody asked, what is the difference between the new Neurotech suite and how does that differ from the field of cognitive science?
Well, the cognitive science, which Angela is in, we have a cognitive science group. So it doesn't differ, they integrate. So all of this at WPI, we integrate everything. We are definitely the integrators of the world. So there is all of the integration that's happening. And I think it's all different aspects of it are really important. So it's bringing all of that together. That's why it's an interdisciplinary program. So we have people in cognitive, we have people in neuro, we have people that together come at it differently. And I think that's why it's so robust. It's because we have people from many different fields.
Fantastic. I think we need to sort of wrap it up with maybe one or two more questions. So there's still a bunch of them coming in. I think we could have gone on for a long time this evening. Clearly a fascinating topic. One question that I think would be sort of a good way to end on a positive note is, as people are trying to think about all the things that you taught us about, the different techniques and things that you can use to try to manage your stress and try to address it, how can people help to identify the kind of coping mechanisms that will work best for them? Some people have tried different things and don't find that something's really sticking or working. So do you have any recommendations on how to find something that's going to work for you?
Well, okay, I'll go through and just ask everybody what works for them. So Angela, what works for you?
So, well, I exercise daily. That's definitely my thing, but I do it first thing in the morning. So even if like my day dissolves into like a pile of dirty diapers and an exploding inbox, I have at least gotten that exercise in. But the big, that sounds like an easy thing. And it sounded like part of the question was like, how do you do it though? And so the way I started was I said, I can wake up 30 minutes earlier. I'm not going to be any more well rested if I get 30 more minutes of sleep versus not. And so started with just start setting my alarm 30 minutes earlier. So whether it's exercise for you, whether it's meditation, whatever tactic works for you, you have to make sure that you engineer your day so that it allows for it and so that it's the non-negotiable. So just like you wouldn't skip a meeting with your boss and you wouldn't not shower, I hope, you also wouldn't skip your stress relief.
Thank you so
Great
much,
tip.
Erin. So what do you do? And you have little ones. You have to tell people that you actually, the house is full, but how do you manage?
I do. So I have 3-year-old twins. I have a 11-year-old, a 10-year-old too. So stress, I can hear them. It's their bedtime. So I might be stressing out everyone else in the family by not helping. But yeah, so I mean, I think the question was also getting at how do you figure out what works for you? And I do think that it's really trying different things and sticking with them for some time and give them a chance. Cause like I know Jean was talking about when she first heard about meditation, it was like, oh, I don't know if this is really gonna work. And I think you can be skeptical or just not have the time or like you're not committed to it. And so then it doesn't end up working. Cause I do think all of these methods at different points in my life, I've used them. Like exercising. There was a time where I did always exercise every day. Right now I try to, and I do the same thing that you were talking about, which is going in the morning. And I try to at least even just 10 minutes, like, if you can't get a whole workout in or something, or get a whole run in, just run a little bit, or just do 10 minutes of yoga and just try to figure out what you can fit in. But I've also started putting it into my calendar. So sometimes it doesn't like work out that I can do it first thing in the morning. And so then I just put it in my calendar. On Sunday, I put my exercise or my own time into my calendar. So it's there as an appointment and you have to stick with it. But yeah, I mean, there were times I did a lot of yoga. There were times I tried meditation. And then of course, now I'm also managing the stress of all my kids and things like that and helping them to build in good practices. But I definitely think exercise is probably like anytime I'm really not handling my stress very well, I stop and ask myself like, when was the last time you exercised? And usually it's been a while and you really can get off balance at that point. So.
Yeah. And I thank you both very much. And I just wanted to wrap up with saying a couple of things. One, I feel that as it turns out, like volunteering and helping other people actually decreases my stress. There is no, the easiest way for me to stop thinking about my stress is to start thinking about somebody else's stress. And that's, as it turns out, is one of the ways that people are showing that really does help. It's that social connection. It's doing something on behalf of somebody else. So I'm better at that than doing something on behalf of me, but I'm working on this because Angela has been on my case, by the way. And the young faculty are like, Jean, what are you doing? You can't exactly say this if you're not doing it. So the meditation piece, I have to say, the first time I went to a silent meditation and they took my phone, I thought I was going to die. I'm like, what do you mean I live without my phone for 2 days? So to be honest, just resting your phone down, just not connecting with technology every single minute. Do you know how much time we spend on it? So there are things you could do. Everybody could do something and start small. You know, like put away the phone for 5 minutes and then 10, or do a lot of things and see what works for you. Just start where you are. Just start today. Like make a commitment to all of us that you're going to start today with one thing. The insight meditation that I told you about, they have 5-minute meditations. You could go, it's called guided meditation, and you pick how much time you could do. So sometimes it's 5 minutes, sometimes it's 10. And I could sit for 5 minutes. We all could sit for 5 minutes. So it's making a choice. And honestly, I know it's hard. It's not easy to make this choice, but making a choice and starting small.
That's fantastic. Thank you each for sharing your research, your tips, your perspectives. Jean, Angela, Erin, we really appreciate all of you being here with us tonight. It was a terrific presentation, really enlightening. I think we all learned something, and I'm really glad that all of our guests were able to be here with us to join us for this evening. I'm sorry that we ran out of time for questions. We had a number of additional ones coming in, but I appreciate you taking a little bit of extra time here with us this evening. Thank you also to my teammates, Aubrey and Jen, who helped manage the technology for us this evening. I want to encourage all of you who are in attendance, especially our alumni, to connect with the WPI community on our networking portal, Tech Connect. We'll drop a link in the feed. This is our alumni platform where technology can, the alumni can connect for networking, job searching, event information, and more. So please do feel free, do connect with us that way. Our next Ask Me Anything program is scheduled for February 25th. It will be featuring Elizabeth Longlingo from the Foisey School of Business. She's going to be chatting with us about leadership styles and power and how we can put them to work in achieving our personal and professional goals. So we're putting a link to that, more information about that program into the chat for people who are interested in participating in that event as well. Again, thank you all for being here tonight. We really appreciate you joining us. I hope you have a great evening, and we look forward to seeing you at one of our future events.